Okay, so in question two, we have a set of two strings. So we have one string that's elongated, and we have another string that's more compressed. We want to go ahead and try to figure out the compression of the second spring. So to do this, we can start by using the formulas that we know. So it's going to be kinetic energy for potential, or kinetic energy plus potential energy plus elastic. So we know that it's going to go ahead and be, we can set up our formula as half of mv squared plus mgh plus half of k plus a equals. So that would be our first part for the first spring. And then our second half of the equation is going to be A equals to half of mv squared, b plus mghb plus half of kvx squared, b. And I did it like that because when you do it like that, you can make both of the equations equal to each other, and it allows you to find the compression. So once we have our formula set up, we can go ahead and now plug in our values that we have for our initial V. It's going to be 10 meters per second. We also have for our potential is going to be 1 N over M. And for our mass, it's going to be 1 kilogram. So now that we know all of our numbers, we just plug in our values. Once we plug in our values, we get 50 equals to 1.10 HB plus half of HB squared. And we can't have the squared. We can't have the squared in the equation. So once we simplify, we have to use the quadratic formula. So once we do that, we get 100 equals 20 HB plus H squared B. So we go ahead and rewrite it into our quadratic formula. And we plug in our values, which would be HB equals M negative 20. Radical sign 20 squared plus 100 divided by 2. And once you go ahead and put that formula into my calculator, you would get that your HB would be 2.5 for the compression. And that would be all for this problem.